Birgitta Böckeler is a distinguished engineer at ThoughtWorks, and I've been chatting to Birgitta for a little while, and actually was really impressed by a post that went viral on Martin Fowler's site that Birgitta wrote, talking about specs and talking about the comparison at the time between SpecKit, Tessel, and Kiro, I think it was. And okay, Tessel's moved on a little bit since then, but it's still amazing to see how many people go to that site. Birgitta's an amazing person. I very much encourage you to follow her. She's very thoughtful with so many posts and blogs that she writes. And a really wonderful way to finish off this conference with a very visionary session whereby Birgitta's going to look at the last 12 months, what's been changing, where we are today, and what we can look forward to. So please give a very AI native dev warm welcome to Birgitta Böckeler.
Okay, thanks Simon. Thanks Simon and Patrick for inviting me. Yeah, so I'm a distinguished engineer at ThoughtWorks, and what that means for me specifically is that 3 years ago I got a full-time role to just be immersed in the space of AI coding, or in general using AI on software teams to help my colleagues, to help our clients. I kind of stay on top of it, so I talk a lot to our teams, our clients, and so on, and then I write about it, for example, on my colleague Martin Fowler's website. And so that's kind of like what all of this is based on. And yeah, it's kind of like a tough task of wrapping up after everybody heard about this topic for 2 days. So I'm going to try and help you see the forest for the trees, or the multiple forests for all of the trees. So I'll kind of do like a recap. I'll start with the recap slide. Simon was briefly confused and thought maybe my slide setup is wrong, but it's kind of like recap a lot of what the stuff that you heard also over the last 2 days, but also kind of what happened in the last 12 months, like advancements as well as things that are maybe not going so well, or that are kind of like all the second order consequences and implications that we're experiencing right now. So that when you get back to work tomorrow and your colleague who maybe isn't as immersed in the space asks you, so what should I know, right? I hope I can help you answer that question. And I'll start with, the reason why all of this is happening, which is the models, so kind of first and most obvious. There wasn't even that much talk about models here at the conference, I think, which is not surprising and totally okay, I think, because for me, this is not really the most exciting part, to be honest. I'm much more interested in everything that's now happening around it, the ecosystem, all of the integrations, and so on. And I mean, obviously, if we talk about the last 12 months, there was the Opus 4.5 moment kind of last year that made a lot of people kind of like come back to this that hadn't maybe tried AI coding for a while. Yeah, so that was maybe the biggest event in models that happened. Like, I mean, almost every week there's a new model, but I usually don't even follow it that much because, like I said, it's kind of interesting to see all the stuff around it. So if we think about models, like what are the core things kind of as users who use them for coding that we need to know or learn, almost like a kind of like learning map, right? So the first thing I always try to get out of the way is that they are not magic, right? They are very, very impressive and very, very useful math. But unfortunately, even like a lot of technologists, a lot of our peers kind of like, it's very easy to fall into that trap, right? Like of thinking of them as more than that, right? So I kind of like this visualization to remind ourselves that, you know, even though we don't really know what's like why it works and what's happening, it's still like very impressive math, right? So first of all, they're not magic. I mention here as the second point their statelessness, because that's also something that I often notice that people haven't quite grasped, right? So the model doesn't have a session, right? So the longer our conversation with them gets, the longer our session with them gets, every single time our agent, our harness, basically sends the whole history of the conversation, right? Maybe not quite, there's caching and all kinds of clever ways that different tools try to optimize that, but they are stateless, right? So that is a factor that happens like the longer our conversations get with them. So I think that's a really important core thing that, people need to understand. The third thing we need to know about is of course, the size of the context window, and in relationship, but also in relationship to what that means for attention, right? So even though technically the context windows have gotten a lot bigger, it comes with a trade-off on like how well the models are able to keep attention on all of the many instructions and all of the context that we're trying to feed them now. So there's something there to be understood by everybody who uses this about what that trade-off is. And then finally, there's and that's maybe the biggest area. So those first things are kind of like, you can learn them in a formal training and kind of like understand the basics, right? But this last one is a lot more about using the models and figuring this out, right? Which model do we use for which task, right? So there's, I mean, these are just like a few illustrative examples, like we have autocomplete, like there's still people who use that a lot. Let's say you want to just change a few specific files and you have very clear instructions and a very clear idea of what you want to do. Or you have a larger and more complex change that needs a bunch of code research before the model actually does it or the agent actually does that. Or you have like tasks like planning, debugging, designing that maybe have a lot more like things like asking you questions and a lot more reasoning involved. So different tasks will have different levels of reasoning that are useful, will need different sizes of context, and will have different levels of need for tool calling. And I actually think that in this area here, we don't even have to know that much about the details of all of the different features of the models, but it's a lot more about us reflecting on these types of tasks, right? Which is something that we've done in the profession for a long time, right? Like all of those like philosophical discussions about what does complexity mean, right? Like that we have in estimations or stuff like that, right? So you have to think about like how many files might this involve? What's the blast radius? How much uncertainty do I still have? All of those things. So I think, yeah, like I said, I think it's much more important for us to work on this like reflection on the types of tasks that we have and then match them to different levels of power that the models have. And if you've been bathing in powerful models for the last few months, then it's actually a nice exercise to remember what we're already taking for granted these days when we try to run a smaller model on our developer laptop, right? And try to see what it can do and what it cannot do. And so here's like an example. This is just to show you kind of the speed, right? The speed has actually come a really long way. So this is Qwen 3.6 running on my Apple M3 with 48 gigabytes of RAM. And it's actually not even that much slower than like some of the stuff that happens in Claude Code with Sonnet or Opus, right? This is open code, by the way. So the speed has actually come quite a bit of a way. Tool calling is still kind of, even with this like quite powerful model that I could hardly even run on a 64 gigabyte RAM MacBook, so it crashed after my first attempts to use it. So even that model was still struggling a bit with tool calling, which is really crucial for our agentic workflows, right? But it also has gotten a lot better than it was like, I don't know, 6 months ago or so. And complexity of all the instructions, I mean, you know, many of you might have seen this when you try smaller models, or I remember when I first used Gemini for coding like a year ago, so I kept getting these as well. So that is still happening, but at the same time, like I was, for example, recently with Gemma 4, which is like a model that everybody's talking about right now in terms of like a smaller model that is quite capable at coding, comparatively, you know, to other small models. And so I used this recently. Again, this was the type of task where I knew exactly what needed to be done, but I couldn't be bothered to type it out myself, right? So I gave it like one small paragraph of instructions, and it was actually really good at doing that. I went after that back and forth a little bit, had it refactor it a little bit because it was quite cyclomatically complex, and then I had my little utility script. So for this, I could actually use it on my M3, right? So again, it's a lot about like knowing the tasks and then kind of mapping that to the level of power you want to use. So moving on from the model, then the next thing that we have around the model is what we've now kind of come to calling the coding harness, right? Or you know, also sometimes more colloquially, it's still like the coding agent, right? So that's the thing that's kind of helping us leverage the model for our coding tasks, and it has things under the hood like a system prompt or all kinds of like other prompts that we usually can't even see unless it's open source, right? I mean, we recently got a glimpse into the Claude Code ones, but a lot of them are, a lot of the big ones that we actually use a lot are closed source, right? It comes, a coding harness comes with the tool integrations, all of the standard stuff that we'll definitely need, right? Changing files, reading files, code search is a big one, right? So we get like a type of code search out of the box, with each harness that we pick. It has like all kinds of orchestration, like most of them have sub-agents now, for example, and also decide when to spawn off certain sub-agents, or they kind of decide like how many tool calls at once they pass on to the model and all of those types of things. Maybe there's some caching involved in some of them. They have a user interface, of course, right? Like some of them have a terminal-based user interface. Some of them are like in VS Code or other more graphical user interfaces. And they also all come with different levels of extensibility and observability. So extensibility, famously, the Pi coding agent is very popular right now as one that has kind of brought that more to our attention, of having a coding agent that we can actually like, that is malleable, that we can change, right? And observability is also a space where there's a lot happening right now in terms of having traces of what the agent is doing. How can we use that to, for example, analyze more like how we can improve how we're using the agent, getting some visibility into, for example, I've done some stuff about like visualizing for myself during a session which files is it reading and which files is it writing, so I could get an idea of like blast radius of stuff. So I think there's still a lot of potential here for us to also make these things part of the review cycle. There are kind of like first rumblings about the bloat, right? We always have the cycle in software, right? We get like a new tool, like let's say Spring, right? And it's like super lightweight, and we're excited because it's much more lightweight than the bloated thing that we had before. And then it takes like a number of years, right? And then we kind of feel like that's also too big, right? With Claude Code, it hasn't even taken a year, and we feel like it's maybe a bit much, right? So here's like a comparison of like when you start out with a session in Pi versus OpenAI Codex versus Claude Code, all of the stuff that's already in there, right? But yeah, so we need to, when we come back to like what do we need to know, right? What do we need to understand as engineers using these tools? We need to kind of like understand these features and how they distinguish between the agents, right? So just to give like an example, I remember when Claude Code came out and it became super popular, I saw a lot of conflation of the interface with the reason why Claude Code was good, right? So I saw that for a while that people said, oh yeah, terminal-based, that's the way to go because it's really powerful. But actually when you have, for example, one of my favorite harnesses next to Claude Code's cursor is also really, really good under the hood with all of those things that you see in the circle below there. So it's not necessarily because of the terminal, right? So this is just like an example of why it's important to kind of distinguish kind of know as the engineer what's actually happening in the tools. So yeah, we have to understand their footprint, understand their features, so that we can use these features effectively, right? And so one of the big things that we want to do is we want to understand how to regulate the context, how to tune the context that we give to the agent with the use of the features that the coding harness provides us, right? So about 12 months ago, the main way that we did that was rules files or instruction files, right? So we would have agentsmd or claudemd and maybe write down the typical pitfalls. And we're still doing that, but these days, of course, there's so many different like features in the coding harnesses that help us do that in a more sophisticated way, right? So there's skills, of course. MCP servers also existed about a year ago as well. There's now sub-agents, there's extensions, plugins, hooks, all of those things. And it's becoming a bit overwhelming and confusing, right? But it's kind of like the storming phase of this technology. And this is also how to use these features is, I would say, was probably at least like 50% of the talks at this conference as well, unsurprisingly. So it's kind of context engineering for coding agents, and that means we're expanding the harness. We're using the features of the harness to help us do this for our specific code base, for our use case, right? Yeah, so we're expanding that harness. So I'm calling it coder harness here. I have to say, like, I'm a little bit unsure. So this is a term that has now gotten traction since February, maybe, of harness engineering, right? Which is basically this, right? Expanding this coding harness. But in other areas, people also use harness engineering to talk about like, how do you make the coding harness itself better, right? So it's still like a little bit clunky term, I would say. I wish we had a better one. I also jumped on the bandwagon and wrote an article about harness engineering. It would be great. Maybe somebody comes up with an even better word. Like the folks at Tesla here at the conference, they've also had this kind of like trifecta that I'm presenting here, right? Like of the model, the harness, and then the context, right? So I think it's reasonable to think of harness engineering as context engineering for coding agents, right? So that's just like to get the terminology out of the way a little bit. So let's look at like how this like area of harness engineering, context engineering for coding agents, like a mental model, like how I think about this, like beyond the features, right? Yes, this is about skills, this is about MCP servers, but conceptually, like what are we actually doing there when we use these features? So one thing, and that's the most common thing right now, is this way of putting conventions, product context, workflow, prompts, like basically markdown files into our code base somehow, right? Or like making them accessible through skills and so on. And in those markdown files, there's actually lots of different things going on, right? We have some normative stuff like coding conventions. We have some informative stuff like, product context, what are we actually doing here? Maybe reference documentation. And then we also have instructions, right? Like, always help me build in the following workflow, or always write a failing test first, or stuff like that. So there's actually lots of different things going on in something that looks just like a bunch of text at first. And then also some of them we just have directly in the workspace, and others are maybe more dynamically loaded from other data sources, right? And so these are all, for me, like kind of feed forward. So we're trying to anticipate what the agent might do wrong, and we're also trying to anticipate, of course, what we want it to do. And we're feeding it all of this information, these instructions, these norms, so that hopefully in its initial generation of code, it's already doing perfectly, right? But as we know, that's not always happening. So we're starting with these guides, but then we also want to give it feedback, right? So ideally, so that we can trigger immediately a self-correction loop before we even look at the code, so that we don't have to like have all those low-hanging fruits still in there. So the most common way that people do that right now is with like code review agents, right? But there's also all of these other tools that we have in our toolbox from before AI, like static code analysis. And then, of course, we can also, an agent usually has access to the logs, so it can start the application, see what logs come out of it. Many people give an agent access to the browser, so it can look at like something when it has changed a web component or something like that. And there's actually a difference kind of between these. So like a review agent is an LLM judging the work of another LLM, right? So it's kind of inferential. It's running on the GPU. But we have a bunch of tools as well that are computational, as I decided to call them here. So kind of things that run on the CPU, right? Like the static code analysis is the best example, I think, to think about this. And we have the same distinction on the feed forward, on the guide side. So we can also think about computational guides on that side. And the best example for me there is code mods. Ian from Meta also just mentioned those. Which is, for example, tools like Open Rewrite that are really good at doing version upgrades and migrations of frameworks. I don't know if you remember, like quite a while ago, Amazon had a really big headline about saving 400 or 500 developer years or something for Java upgrades. That was under the hood, actually mostly code mods being made available to AI. So that combination is really powerful, right? So all of these things, or maybe providing a different type of code search that is more effective for your really large code base. All of those are ways, again, to increase the probability that AI does what you want in the first go. So that's then the expanded harness. And then as a human, as we've heard in a few talks here as well, as the human, our job in part becomes kind of steering this set of guides and sensors. So as Mitchell Hashimoto says in his blog post, it's the idea that anytime you find an agent makes a mistake, you take the time to engineer a solution such that the agent never makes that mistake again. And of course, AI can help us engineer those little solutions, right? Which is really useful. So just two quick examples to bring that home. So here's like something in the agents MD, do not use console log. You know, we have a custom logger that does structured logging and so on. It's in the following place, right? Instead, I could have like a linting rule that I customize, where I customize the message and point the agent at that log file through that, right? So especially when you have things that it doesn't even do wrong that often, it happens maybe once a week, it's much more effective to have this linting rule than to like stuff it into your context every single time the agent runs. Or here's another example. Let's say you have a backend coding conventions skill that talks about the backend layers that the agent should respect in terms of like which modules are allowed to call which other modules. There are some tools in most language ecosystems that help you scan the different imports between files. And so again, you can like come up together with AI with some rules in those tools that help you already catch the low-hanging fruit of those modularity violations. And then you should think about like where you put those sensors when you run them, right? So kind of like strategically think about your path to production and think about when you want to run them. So do you want to run them in the coding session, right? Which is, I think, whenever that's possible in terms of like how cheap is it, how fast it is to run a sensor. I think you should run them like even before you commit. Right? So I have this box here about integration, right? So it kind of like depends what that means for you. So probably 80% of my commits in the last 15 years have been put straight onto the main branch, which is probably not the case for most of you. So integration could either be like for you to say, okay, I want to do all of those things before I even create a commit, or it could be as part of the pull request process where you run some additional like inferential sensors or something like that, right? Then we have lots of stuff in our continuous integration pipeline already, right? You probably don't want any inferential sensors in there because you don't want, you know, the green or red state of your pipeline to depend on semantic interpretation of an LLM, right? But we have like lots of computational sensors in there. And then also what I've heard a lot of stories now about teams doing in ThoughtWorks, and also lots of people writing about that. Also the team, Ryan's team, who had a presentation yesterday at OpenAI, they call it garbage collection, right? So kind of like continuous drift detection for the technical debt that still accumulates, where you can probably put like a lot of inferential sensors, right? So in the code base where I'm setting up all of these things, I have like a modularity review, like a dependency freshness review, security review that doesn't run every single time the pipeline runs, but I trigger it maybe like once a week just to see if there's something new that came up. And these like continuous drift detection things, they probably also like require some kind of process on your team to deal with them, right? There's a lot of parallels to, for example, security vulnerabilities and how you deal with them, right? Like, you know, they keep popping up again. Do you want to suppress them because you cannot fix them right now, but then you might forget about them? So I suspect we'll have all of these challenges there with this type of stuff as well. Like, how is the team going to deal with these? Again, you can maybe like have AIs, of course, like create, you can have agents create pull requests for you, but still, how do you deal with those, right? And then finally, I should also mention, there's, of course, also this way of having sensors like in production that you give AI access to, right? Especially when it comes to your architecture fitness, things like scalability, latency, all of those things. There were a few talks here at the conference as well about using observability data and, you know, both to help you fix incidents, but also just to like monitor how you can make your runtime better. Okay, so as users of coding agents, we have to know a few key model capabilities, and like I said, kind of like have good reflection on the types of tasks that we're using and what complexity means for us in relationship to what models can do. We should understand the key features of harnesses and how they differ, and not just like look at them as like, you know, these blobs, and one is a terminal and one is an IDE. But the biggest area is really this, like, how do we use them to our advantage, right? How to apply this tool to our domain, which is software engineering. So with all of these things like models getting much more capable, harnesses getting much more capable, we're kind of like getting more sophisticated in figuring out how do we use this, how do we provide our context. So this kind of like race continues, right? We want more agent autonomy and we want less human supervision. And as part of that, also something that has happened over the last 12 months is that it has become a lot easier to run agents with no supervision, right? So this screenshot is from like, I probably took it last year in June, July or something. That was the first version of Codex. And over time now also most of the harness products, the coding agent products have now come out with like platforms where you can always decide like, do I want to run this coding session locally on my machine or do I want to do it in the cloud? And so it's become a lot easier to do this and to try this out, right? Like whatever size you feel comfortable, size and complexity of tasks you want to do this for. Like some people run it to actually like build full features and others maybe like just dip their toes in, like clean up this feature toggle or like small cleanup tasks, right? And also in the meantime, we've kind of like taken this like to more extremes, right? Which is more an experimental stage right now, I would say, which is this idea of like swarms or really brute force, just sending lots and lots of agents out there and also having the agents decide how many agents they need, right? Gastown got a lot of attention in, I think it came out in January. There were these two like big or even more experiments from like Cursor, for example, or Anthropic to build C compiler in the browser. Claude Flow, I think it has a different name now. That was probably even earlier than Gastown last year. Kind of people were playing around with that. So that's kind of like taking it to the extreme and seeing how we can push the boundaries and actually have AI build much bigger things more autonomously. Yeah, so this is our fourth year into this. So we start with autocomplete, and we had a bit more like integration into the IDEs, more context. Claude 3.5 Sonnet was like an early model moment, I think, where I certainly from that point on just almost always use Claude Sonnet because it just like felt so much better at coding than the other ones. So then we got these like, at the time, most people, or I also in my presentations, still call it agentic coding modes, right? So that's when like Cursor and so on, they got like these modes where they could also run terminal commands, which had been a thing that was already out there in open source, but not as widely used, and MCP. So that was only about 1.5 years ago. Then shortly after that, the vibe coding term got coined by Andrej Karpathy, which then led to like a lot of attention of people discovering these new agentic modes and going, oh, this is like, so there was like a wave of like people picking this up again and saying, oh, this has actually improved quite a bit. Then we got these kind of background agents that I just talked about, right? Like so Codex, for example, you know, allowing you to run things unsupervised in the background. Claude Code is, I think, generally available, probably about a year old. It's like, it started a little bit earlier than that. The context engineering term also started gaining traction about a year ago. Then we had that Claude Opus moment. We got skills. OpenClaw is maybe also a relevant moment, even though it's not quite directly about coding. And then, yeah, so like kind of beginning of this year, we got this like next wave of people paying attention again and going, oh, this has actually changed quite a bit, right? I can actually see those two yellow spots in our internal AI coding chat community in ThoughtWorks. I can see the spikes in activity and then kind of like holding, and then there's like another spike of like, I don't know, 250 messages a week or something, median. Yeah, and then so yeah, the Gastown and all of the swarms and all of that started, those big experiments started happening at the beginning of this year. Then the harness engineering term is now like a buzzword. So, and you know, I don't have any additional boxes here because I think right now it's like us all like processing, right? And actually using all of these things that are happening. So there's been like, I think not like a big coinage of anything or like a new buzzword other than these things, but we're just like grappling with it and using this stuff, right? So it's come a long way, but the costs have as well. And I don't just mean the token costs. So one is security, right? So it's both about like secrets potentially leaking from our environments, from our machines, but also our ecosystem is under attack, right? So we have to like think even more than before about dependency management, about sandboxing and stuff like that. On the other hand, there was also a good talk by Joseph from GitHub here yesterday about like how we can use AI to improve our security, right? So there's usually both sides to it. Stability, right? So in the DORA report, this was one of the big, like, let's say, negative trend findings about stability actually getting worse according to their data. But also there were a lot of talks here about like how we can use AI to help us improve our stability. Then changeability is a big thing, right? So like code quality defined as code that remains easy to change and where it remains easy to change it with low risk, right? So this was a change I recently introduced into a still relatively new code base that was all created with AI. And I made a change that touched 41 files, but it shouldn't have. It wasn't like that big of a deal. And so it was like a clear smell that there was already like accumulated tech debt that was making changes more risky and more costly. So, but then also here the question is like, how far can we push this more and improve this more with guides, with sensors, with static code analysis, and so on. Token cost is the most obvious cost thing, of course. In the beginning of 2024, I was at a keynote presentation where the speaker said, generating 100 lines of code only costs about 12 cents. Can you imagine? And he was comparing that to developer salaries. I mean, regardless of, lines of code is not a measure of value, right? Let's just get that out of the way as well. But of course, now we have like, there was some numbers or some quotes in the Pragmatic Engineer newsletter recently where somebody, for example, there were multiple of these quotes, but somebody said some developers are now spending $500 a day, which if we take that analogy of a developer salary is over $100,000 a year salary, which is a pretty decent salary even in the richest countries in the world, right? Another type of cost is like cognitive load and burnout, right? Like, who would have thought, right? It doesn't actually make our lives more relaxed. On the contrary, right? Like some people are working more, even though they already create more output. And Steve Yegi had this analogy with the energy vampire from What We Do in the Shadows. I don't know if any of you have seen that show, but he basically, he's a vampire that doesn't suck blood, but that sucks energy. So there's lots of stories about people saying, oh, I can only do this like 3 hours in a row, and then I have to like take a nap. Then we have the review crisis, of course, right? We have like higher coding throughput, but then if we can code faster, can we review faster, test faster, ship faster, review faster? We've definitely, so far the state is no, we cannot review faster, right? Everybody's complaining about this pain. But it's not just coding. Everybody can create more with AI now, right? So I was talking to a colleague the other day who was telling me a story about an organization on this side of like, if you can code faster, can you fill the backlog faster? So here, there was like another kind of like thing popping up before the coding where the product managers were actually like churning out lots and lots of prototypes and lots of ideas, right? So now there was this weird like bottleneck between this pile of prototypes and the pile of code because they couldn't get it like to sync up again, and nobody really could figure out how to converge on what they actually wanted to build because they were doing this kind of like in these two silos. So that's maybe like something like an open question that we're already seeing a little bit, but are we heading in general towards like a flow crisis, right? And whenever I want to understand flow better, I turn to my colleague James Lewis, who like has done a lot of very interesting presentations about flow that it's easy to find on YouTube. But here's one where he's talking about congestion collapse. And so he has this prediction. Apparently, he has a bet open with Gene Kim for a crate of beer that this will happen and that this will become like a big topic of conversation. That we're just like overloading and also overloading in these different silos, and that everything will just become super slow at some point and just collapse. So this comes, from I think theory of constraints and stuff like that. And here he's quoting the Don Reinertsen book about the principles of product development flow as well. So then humans are seen as the bottleneck, right? That's what multiple people also quoted or said here at the conference. So it remains this big question of like trust in the code and how much supervision do we want to have and how much review, And of course, it depends, right? So the autonomy of AI coding agents is here. It's just unevenly distributed, right? Lots of you are probably already using it for some things, right? But I think it will never be that we can use AI coding agents for any type of task in any situation, right? It's just always, it depends on the situation. And what does it depend on, right? So for me, the way I think about it right now is as this risk assessment out of probability, impact, and detectability, right? Which is very typical kind of components of risk assessment in all kinds of areas. So first I think about the probability that AI gets something wrong or gets something right. And that's all about me knowing the things that I talked about before, my AI tool, like what my context is, did I even give the agent a chance to do it right? And it's also about me reflecting on my confidence in my requirements, right? Like how certain am I even that I even know what to do? Then I think about the impact if AI gets something wrong. So that's all about the use case criticality, of course. So is this like a super critical business flow that, will wake me up at 2 a.m. on Saturday because I'm on call? Or is this something a lot less important? Then maybe like I'm a little bit more loose with how I review. And the third thing is I reflect on detectability that AI got something wrong. Will I notice, right? And by the way, all of this starts with knowing what right and wrong means, right? And often that's like, is it appropriate, right? So you have to know your feedback loops, basically. And then based on these things, I decide which workflow do I use, how much review do I do, and how long do I let it go without supervision. For example, if I don't even know myself yet quite what I need, then I won't let it go off for like half an hour and then realize that it was all for nothing, right? And yeah, so you have to kind of be this tall to ride the roller coaster. You have to be this tall to reduce supervision, right? So you can think about, feedback loop in your team, in your organization, and you can also increase the probabilities by improving your context engineering, your harness engineering, and also refactoring and modernizing, and all of those things, because AI can also deal with a well-factored code base much better than with a messy code base. So we're tempted to move from in the loop to on the loop to out of the loop. I feel this every day, being drawn to like, I don't want to look at this. I don't want to look at the code anymore. It's like, there's all of these forces that pull us there. But we're also starting to actually feel the costs. It's not just speculation anymore. It's not just like dooming kind of predictions. We're actually feeling the cost of tokens, risks, and cognitive X, right? Cognitive load, cognitive debt, right? This idea of like, we don't even understand anymore how our code base is structured. I sometimes think of like cognitive deferral as well. It feels like we keep like deferring the review to other people, or like deferring processing what actually happened. And recently, there was like a new cognitive X term coined that I saw because Adi Osmani wrote about it, which is cognitive surrender, right? So in this paper, they put AI into the context of the system 1, system 2, thinking fast and slow. I think probably lots of you have heard about that book. If not, then look it up. It's like really great. And so they're talking about a mode where we're basically displacing system 2, like our actually like active thinking with AI, and they call it cognitive surrender. And apart from like this paper and the cognitive part of it, this term like surrender has just been stuck in my head like ever since I heard this. And I feel like there's like so many things where we're in danger of just like surrendering right now, not just cognitively. And so I think we have to be careful about what we are surrendering, right? And like really think about, be mindful of where that's worth doing. So I'll just give like some examples, right? So it's like, it's too much to reason about this big change. It'll be fine, right? I do it myself. I just do it myself quickly instead of teaching somebody, right? Everybody's talking about, how will juniors learn? How will we do this? But I don't see that much like active action, right? Because everybody's just in a tunnel of, I see experienced people building tools for themselves to use AI better. But like, why are we not taking more initiative to think about how this is sustainable for people who don't have all of this experience already? Or this like, I'll just use a big model, I can't be bothered to then like retry it again, so let's just use the most expensive, biggest model. Or the surrendering to like, I don't want to solve all these problems. Models will get better, tokens will be cheaper again. We just have to wait it out, right? We're working more, we're producing more, but we're still getting the same compensation. Is that also a type of surrender? Or this like, I don't have time to find better approaches, which is, by the way, not necessarily the individual's fault. It's also like what's happening around them and the incentives and pressures, right? Sandboxing is too tedious. Surely nothing will go wrong, right? Or I can't work on this code base without AI anymore, right? That's the original cognitive surrender, cognitive debt kind of definition. This was like Hannah yesterday in a talk, and she was kind of talking about what she's keeping, what she's trashing, and what she's trying. And I think that's similar in terms of like we have to think about what we're surrendering and what we should be keeping. So if you are a person of influence in your engineering organization, are you creating an environment that leads to surrender, right? That makes people feel like they just have to crank out the PRs and don't have time to like actually figure out how to improve the environment, how to improve the context engineering, and so on. If you maybe feel a bit like powerless, or you feel like you can't influence it and there's all these pressures around you, still like try to think about your sphere of influence and the small things you can do. Like what do you really have to surrender, right? So there's lots of options between not using AI at all and like just total surrender and hoping the models will fix it all in the future. And again, like if you feel kind of like powerless and like this is like washing over you, we can also work together and collaborate on these things, right? So if you feel like you're not a good communicator about this, maybe look for somebody in your team or organization who's good at that and share your data, share your observations with them, right? So like we can collectively do a lot about this as well. In terms of skills, we need to know our toolbox, past and present. We also need to rediscover some things. We need critical thinking, risk assessment, and some form of like patience, right? So we need to evaluate that productivity maybe doesn't just mean like typing. And for leadership, you know, this is still Horizon 2, right? This is not Horizon 1 yet. So maybe we don't know the ROI yet. Maybe we just have to like give people some time to create a good setup so that we can continue to safely and quickly deliver software to users in a sustainable way. Thank you.